I'm Matthew Drescher, and I'm affiliated with UC Davis. My work is about processing graphs on GPUs and basically mapping them to the hardware. And the challenge there is that real-world graphs are very irregular, and hardware loves regularity. Also, our algorithms also love regularity. So when we're trying to process these irregular things, we need to do things a little differently. For example, in the poster here, we see that the network on the right has these two orange vertices, which are connected to almost everything. Everything else has very few connections. On the other graph, it's more regular. All the vertices have almost the same degree. That graph is much easier to deal with both algorithmically, and it maps nicely to our hardware. So one technique that we can try to do to improve the cache locality of these irregular networks is to reorder the vertices. And so like on the right here, we see this, it looks like a static fuzz. What that is a matrix representing about 75 million journal citations. And it's just ordered randomly. And what we can see is that the cache will load these lines and they'll be mostly zeros, very few non-zeros. So every time it loads a non-zero, you'll have to load, mostly zeros. So you're wasting a lot of cache lines. So what we try to do is find a nice way to reorder that data. We can see that the other picture is much nicer. It has a lot of structure. Some might even say it's beautiful. And the data is clustered along the diagonal. That makes it much easier for the hardware to load multiple non-zeros per cache line. So there's various ways that we can come up with this type of reordering. One idea is to model it as an optimization problem and then try to approximate that. So we are experimenting with different ways of doing this really quickly. We can see our results down there in the chart where we're getting upwards of about 70% speed increase and based on doing very little. So that's the extent of this work. We are writing a paper on it now. Hopefully it will be available, submitted soon.